All right. So this lesson, we'll finish off our Unit 1 for Course 2. And you'll find that algebra skills have a lot of similarities to the English language and how words fit together and letters fit together. So I'm going to use a few analogies of how you can understand math by understanding English, okay? So there's a few key terms, key words you need to know. And when we're simplifying, make sure we're using the right words here. When we're simplifying algebraic expressions, we're not always going to find like the answer or find out what the variable is. Okay, because a lot of times in algebra, we're trying to figure out what the variable is and solve an equation. But when we are simplifying expressions, we're not really finding like the final answer, okay? Similar to how letters in the English language are put together to form certain words. And if you put them together randomly, it just forms a bunch of gibberish. But you have to put them together intentionally, with purpose and with organization to make words, make sentences, okay, to make structure when using letters. So a similar concept applies with both numbers and variables in algebraic expressions. So let's quickly go over these three words you need to know. A term. Okay, so a term is anything in an algebraic expression that is separated by a plus sign or a minus sign. Okay? And here in a minute, we'll do some examples, and this phrase, term, will make a little more sense. Okay? A coefficient is simply the number that is attached to the variable. And when I say attached, what that really means, it's multiplied by the variable, okay? Because any number that is directly next to a variable or attached to it automatically means multiplication. Sorry, I had to shut the window there. There's a lawnmower outside. It's kind of loud. And our last term, or our last really phrase, is like terms. So we have term and we have like terms. Like terms are parts of an algebraic expression that have the same variables or same letters and the same exponents. And again, just a minute, we'll be able to see sort of these definitions come to life in these math problems, and hopefully they'll make a little more sense to you. Okay. So these first few problems, we are identifying like terms. Okay. So remember, like terms have the same variables and the same exponents. So let's look at number 1. We have 6a would be a like term with 6a. No, it would not, because the variables are different. A and B are different variables, okay? What about just a? It actually would, okay? Anytime it's just a variable by itself, it's the same thing as having a 1, like 1a, 1 times a. Okay, so we have the same variable a, and they both don't have an exponent, so it's the same exponent, okay, if they both don't have one. So yeah, these are alike, okay, 6a and a. Anything else in this list that looks kind of like 6a and a? Okay, 17 doesn't have a variable, so it's not a like term. 4b, nope. 32, no variable. And then here, 17a, they all have a's, and they all have no exponents up there. So they are like terms, okay? Are there any other like terms that we can see? Yes, look at the b's right here. I'll put a box around this one. So we have, this is like a 1b here, no exponent, and then 4 b's. So the b, the variable, is the same, and the exponents are the same. Don't worry about the coefficient, okay? So in this case, like 6 is the coefficient, 4 is the coefficient, 17 is the coefficient, the number attached to the variable. Doesn't matter if those are different right now. Worry about the variable and the exponents. And then lastly, we have, we'll just make a little star here, 17 and 32. Both of them don't have a variable, and both of them don't have an exponent, okay? Really, if it doesn't have an exponent, you can think of it as an exponent of 1, but you don't have to worry about that right now, okay? So there we go. All right, we need to speed this up a little bit. So let me walk through one more, and then I'll quickly go through the rest of them. Okay. So let's look at x. Is there anything else in this row of terms that has an x and doesn't have an exponent? Well, this one doesn't because the exponent is 2. Okay. Here we go. This has an x and there's no exponent. So these are like terms. Okay. And that is it for x. What about x squared? Let's underline these. X squared. Well, 3, there's no variable, no exponent. Here we go. There's an x, yep, in both of them. And there's x squared in both of them. So the variable and the exponent are the same. And then to finish it off, we'll make a box around 3 and 6 because neither of them have variables and they don't have exponents. So 3 and 6 are like terms. All right, let me quickly fly through the rest of these without talking a whole lot. If you need to slow down or pause it, feel free to do so. All right, 2 and 3 don't have a variable, don't have exponents. 6z, z, and 17z. They each have z, and they each have no exponent. And then 6z squared and z squared both have z, both have an exponent of 2. M and 12m, they both have an m, no exponent. 8 and 18, no variable, no exponent. Oh, missed something. Look, 8m, here we go. Fits in with m and 12m, okay, like terms. One variable, one exponent. And then 8m squared, variable, exponent of 2. M squared, same variable, same exponent. All right, let's stop there, and then let's actually go down here to get some different kind of work done. Okay, we are combining the like terms. So up top, we just identified them. Now we're going to put them together. All right. So 6p squared and 3p squareds. Well, are these like terms? Yes, they are, because they each have p and they each have an exponent of 2. So think of it in terms of how many p squareds are there. So how many p squared do we have? Whoops, sorry. Well, over here we have 6 of them. Over here we have 3 of them. If we combine 6 and 3, like normal addition, we would get 9. Okay. So we have 9 p squareds, and that's our answer. All right, we're not trying to find out what p is. We're just trying to find out how many p squareds we have. Okay. All right, here we go. 9x minus 6x. These are like terms. Both of them have an x. Both of them only have one exponent. So if you treat this like normal subtraction, 9 minus 6 would give you 3. So think of x. Let's just think about if x is dollars or x is marbles. Okay, if you have $9 and you take away 6 of those dollars, you're left with $3. So same concept here. 9x minus 3x equals, or minus 6x equals 3x. All right, that's our answer. Okay, here we go. It might help you to circle the like terms first. We have an a squared Can I combine that with b squared? No, I cannot. You can only combine like terms. Okay. If you didn't catch that earlier, you cannot combine terms that are not alike. Okay. So I can't combine the b squared and a squared. Okay. I can combine these two right here, a squared and 2a squared. So if I have one a squared right here and I add two more a squareds to it, think of it in terms of dollars. If you have $1 and you add two more dollars, you have three of them. Okay. So I now have three a squareds. One right here and then two over here. Okay. 1 plus 2 is 3. And then I have some b squareds that I have to combine. All right. So I have one b squared. One. That was a really bad one. Not sure why I did that. And then I have 5 b squareds. If I add them, because all of my signs are addition here, I get 6 b squareds. Are there any more like terms left over from my new expression that I can combine? There are not, because a and b are different variables. Okay. Yes, they have the same exponent, but both the variables and the exponents have to be the same. So this is as far as I can go. That's my answer. Okay. 7h squared. Can I combine that with 3? I cannot, because 3 does not have an h attached to it or a exponent of 2. So I can't combine that. So if you write something like 10h squared, that is not correct. Some people will try to do that. So see if you can catch yourself if you're making mistakes like that. All right, but what can I combine? 2h squared and h squared. They both have the same variable h and the same exponent of 2. So 7h squared minus, make sure you remember, see the signs here, the operations, minus 2h squared. So $7 minus $2 gives you $5 or 5h squareds, right? And then left over we have a plus 3 and a plus 4. I can combine those because those are just numbers. There's no variables, no exponents, so they're like terms. 3 plus 4 is 7, so plus 7. So 5h squared plus 7 is as far as I can go. I can't combine this and make it like 12h squared. That does not work. Some people will try to do that. It is not right. All right, another minute or two here. Let me just quickly go through these other ones. Work through these on your own and see if you can get these right. All right, so to finish up here, if you notice, there's 3 terms. They're each separated by an addition or subtraction sign. I can't combine b or b squareds here because they don't have the same exponent, and I can't combine this 10 with anything else because they don't have the same exponent or variables. So this is as far as I can go. 7b plus 6b squared minus 10. All right, that's the end of the lesson. We'll do some more practice on this in class because this is a really big concept for kids to understand. So, you know, if the video didn't quite hit everything we needed to practice, that's okay. We'll have more time in class to work on things. Thanks for watching.